Logistics engineering. Logistics engineering is a field of engineering dedicated to the scientific organization of the purchase, transport, storage, distribution, and warehousing of materials and finished goods. Logistics engineering is a complex science that considers trade-offs in component/system design, repair capability, training, spares inventory, demand history, storage and distribution points, transportation methods, etc., to ensure the thing is where it's needed, when it's needed, and operating the way it's needed, all at an acceptable cost. Overview. Logistics is generally concerned with cost center service activities, but provides value via improved efficiency and customer satisfaction. It can quickly lose that value if the customer becomes dissatisfied. The end customer can include another process or work center inside of the manufacturing facility, a warehouse where items are stocked, or the final customer who will use the product. Another approach which has appeared in recent years is the supply chain management. The supply chain also looks at an efficient chaining of the supply, purchase and distribution sides of an organization. While logistics looks at single echelons with the immediate supply and distribution linked up, supply chain looks at multiple echelons/stages, right from procurement of the raw materials to the final distribution of finished goods up to the customer. It is based on the basic premise that the supply and distribution activities, if integrated with the manufacturing, logistic activities, can result in better profitability for the organization. The local minimum of total cost of the manufacturing operation is getting replaced by the global minimum of total cost of the whole chain, resulting in better profitability for the chain members and hence lower costs for the products. Logistics engineering as a discipline is a very important aspect of systems engineering that also includes reliability engineering. It is the science and process whereby reliability, maintainability, and availability are designed into products or systems. It includes the supply and physical distribution considerations above, as well as more fundamental engineering considerations. Logistics engineers work with complex mathematical models that consider elements such as mean time between failures, MTBF, mean time to failure, MTTF, mean time to repair, MTTR, failure mode and effects analysis, FMEA, statistical distributions, queuing theory, and a host of other considerations. For example, if we want to produce a system that is 95% reliable, or improve a system to achieve 95% reliability, a logistics engineer understands that total system reliability can be no greater than the least reliable subsystem or component. Therefore, our logistics engineer must consider the reliability of all subcomponents or subsystems and modify system design accordingly. If a subsystem is only 50% reliable, one can concentrate on improving the reliability of that subsystem, design in multiple subsystems in parallel. 5 in this case would achieve approximately 97% reliability of that subsystem, purchase and store spare subsystems for rapid change-out, establish repair capability that would get a failed subsystem back in operation in the required amount of time, and or choose any combination of those approaches to achieve the optimal cost versus reliability solution. Then the engineer moves on to the next subsystem. Terminology. There are few differences between the terms business logistics and logistics engineering. Logistics engineering is more focused on the mathematical or scientific application of logistics. Fields and topics. The various fields and topics that logistics engineers are involved with include performance metrics. Different performance metrics, measures of performance, are used to examine the efficiency of an organization's logistics. The most popular and widely used performance metric is the landed cost. The landed cost is the total cost of purchasing, transporting, warehousing and distributing raw materials, semi-finished and finished goods. Another performance metric equally important is the end customer fill rate. It is the percentage of customer demand which is satisfied immediately off the shelf, from on-site inventory. An alternative to fill rate is system availability. In recent years, the United States Department of Defense, DoD, has advocated the use of performance-based logistics, PBL, Contracts to manage costs for support of weapon systems. Education. Many top universities offer logistics engineering programs at undergraduate and graduate levels. These programs generally combine strategy, operations, facility design, technology and management. The following institutions provide logistics engineering programs around the world.